Hi there. Hi, Nikolai. Glad to see you here on our community meeting.
Hi there.
Hi, Andrei.
Hello.
Oh,
Hi, Kingdom.
somebody from Flux community. It's Stefan, I think, or not?
It's Kingdom.
No. It's Kingdom.
Oh, sorry, Kingdom. Yes, I forgot you from Flux. You are just like
How can you forget it?
our salt of earth, or how it is in American.
Okay, let's wait for a few more minutes. Maybe somebody else will join.
I dream about Cozystack community meeting that will gather guys like Cozy Summit, 100 or a few hundred people.
I was on Cluster API meeting. They had about 50 people joined in one time, and they had strict requirement that if you want to tell something, it's really difficult to put your words.
You need to make this 100 pushes before it.
Yeah, you need to raise your hand or do some stuff like that.
Okay, get it.
But still, that's interesting how CNCF organized this kind of huge meetings. They always try to split them, but there are some main meetings, and sometimes, I don't know, maybe they already split that. Here is my cat. Or it's not time today. Doesn't like me. All right, then I think we can start. I'll share my screen. And I'll post link to the chat. So welcome everyone on biweekly Cozystack community meetings. If we have somebody new on this call who didn't introduce yourself previously, it's a time to introduce yourself.
So I'm Nick. I work on a project called Coroot, which is open source observability platform.
Thank you, Nick.
Cool to be there.
Thank you. I have to repeat that we have a Telegram group where you can ask your questions. Also, we have a Slack channel and official Kubernetes Slack. You can find links here in this doc. Please put your names in this document. And today in agenda, we have few topics to discuss. First, I would like to put a few information about the upcoming changes which will be released in 0939. First, we are going to switch to Flux all-in-one installation to have less dependencies at the beginning and finally solve this chicken and egg problem. We found a really interesting solution. How can we actually access our HTTP server through the Kubernetes API? I think the new article will be published soon about that. Also, we are going to introduce application versions for Postgres, MySQL, Redis, and Kubernetes. Kubernetes is available already, but we will manage it more better way. And we have two long-term features. I would like to ask Timothy to talk a little bit about backup state.
Sure. Hi, everyone. Will you introduce the full agenda first, or shall I get started?
No. Yeah, let's get started.
Yeah, okay. I already talked about the backups feature at Cozy Summit last week. So we took some inspiration from the cluster API to make something truly composable. In the core Cozystack controllers, we will only have some basic resources that define the general logic of backups. That you've got a backup schedule. We call it a plan. That you have some kind of storage, I guess. Although we're still ironing out the details. And then you have pluggable backup strategies that can be custom tailored for any sort of application for backing it up in any kind of manner. So, for instance, for virtual machines, you need to freeze the virtual machine and then take a snapshot of the volume and ship that to some external storage and then unfreeze the virtual machine. Whereas for something like Postgres, you've got native capabilities to back it up, including backing up the write-ahead logs and whatnot, and enable point-in-time recovery. And because it's impossible to plan ahead for every possible application, we intentionally are designing this system so you can have pluggable controllers that are able to handle backups for anything you throw at it. If it doesn't do what you want it to do, you can always write your own plugin, and it will integrate with the core backups API. The general design of the backups API is available in our repository, but it's hidden a little bit deep. Andre, if you could maybe, I don't know, paste a link to that to the design document. It's in API. You know where it is, yeah? API backups V1 Alpha 1 and design MD.
Thank you. I just wanted to invite community to discuss this backup solution as well. There any implementation phases described somewhere in open source community?
Yes, there are. I was decomposing the task quite a bit today. So if you look at the open issues.
Is it?
Yeah, that is one of them, and it has subtasks as well. Yeah, that's the main issue, and it has some subtasks already.
Thank you. So I'll save it here. I think the community will be able to find the backup plans and design. Thank you. Do we have any updates about Talm UI?
I'm not sure if Ivan is with us today to discuss it. Is he?
Yep.
Yeah, he's here.
I gonna show it tomorrow.
All right. So
saved,
next meeting we will see some demo probably. Thank you. That's it. This meeting we have invited Nikolai who is a Coroot maintainer. Lately, we get some requests to include Coroot in Cozystack. So I invited Nikolai to this meet to make a short introduction about what is it, why is it needed for, how it works, and consider the integration. Stage is yours, Nikolai. Thank you.
Okay, well, Coroot is an open source observability platform, like all in one. And the main differences between, other, we have a lot of observability tools out there, like Grafana, Prometheus, and anything. But Coroot is something already ready-made and integrated. So when you install Coroot, for example, into a Kubernetes cluster, it installs everything from agents to time series databases and log storages, and more it's like provide you with a comprehensive UI with some predefined inspections. So you can spot root causes and issues within your infrastructure without any efforts integrating, like because of, when you install, for example, Grafana plus Prometheus or Victoria Metrics or anything else, you have to start from scratch. You need to find the right metrics exporter, log shippers, and so on. With Coroot, you will have everything out of the box in a few minutes. And additionally, our agent is based on eBPF, so it can track service-to-service communication. It can track latency between every component, so you can see the big picture of how your system works without the need to change your code, redeploy it, and instrument it manually. Additionally, Coroot supports OpenTelemetry as like you can integrate OpenTelemetry SDK and send traces to Coroot and logs, and it will store them in ClickHouse. But on top of them, it provides you with pretty useful UI that aims to help you find the root cause as quick as possible.
Maybe do you have
That's like
some demo installation to show how it looks like?
yeah, for sure. Let me just.
Is Coroot is open source or CNCF project?
Yes, not CNCF, but open source under Apache 2.0 license.
All right, so no legal limitations.
Yeah, for sure. We wanted to be okay. Here is our demo. Here we have a bunch of services deployed on a Kubernetes cluster that communicate with each other. And this service map is built on top of eBPF. So here we don't use any OpenTelemetry integrated data. As we can see, Coroot built an actual service map, and we can easily understand how our components communicate with each other, including latency, the number of requests, and any issues. So if we drill down into any particular service, we can see its clients and dependency services and databases. And out of the box, Coroot tracks SLOs. Like you haven't defined it, but it's already tracked because we have some predefined defaults, thresholds. For example, for services, we have 99% of availability SLO, so we expect our service performs without errors, and latency objective. We expect serve 99.9% of requests faster than 500 milliseconds. So if something goes wrong and the service started to violate their SLOs, you will be notified through many notification integrations such as Slack, Microsoft Teams, and so on. Even like you can customize it through webhooks. So you can integrate Coroot with your custom system using webhook mechanism. And additionally, about each application, we know a lot, such as number of instances, where they run, Coroot tracks. Here we have predefined inspections. For example, if we have the number of available instances less than we expect, this inspection will be marked with a yellow indicator, so you can easily understand that here we have everything okay with CPU, memory, network, DNS, but we have something interesting in logs. That's the idea, to have predefined checks that help you navigate and find the root cause really quick. So also we have a lot of metrics about each component, each container, but the most interesting of them, like network metrics, it's because, usually when you install Prometheus Node Exporter, you will have only network interface counters in your Prometheus, like the number of packets received, transmitted on the particular interface, but it can't help you to investigate packet loss or network latency. With Coroot, you have everything out of the box, because our agent measure latency, network latency to every TCP connection. So we can understand what's happened with network routing time over time, and also it calculates TCP transmissions precise to any database and service. It's pretty useful when you troubleshoot network-related issues. Also, with DNS, Coroot's agent can capture DNS requests, measure its latencies, and understand the statuses of each DNS request. It shows DNS errors per destination domain. It's also pretty useful, especially on Kubernetes, where DNS is a primary way for service discovery. And concerning logs, Coroot's agent automatically discover logs and ship them into ClickHouse, but additionally, it also extracts repeated patterns right on the node. So you can easily understand the type of errors. For example, I worked at a SRE many years, and I observed how engineers work during the incident, especially with logs. They try to mentally clusters their logs into some sort of types of errors. And Coroot does this automatically without any configuration. It can detect severity of each message and group them, cluster them into repeated patterns group. It's pretty useful. For example, here we have some sort of errors, and if needed, we can drill down and see the particular messages that matches this pattern. Additionally, Coroot uses eBPF to gather eBPF-based CPU profiles. So for languages such as Golang or Java with some adjustment, you will be able to explain CPU spikes, for example, precise to the line of the code. So it can unwrap application stacks and show you the flame graph. Additionally, you can select any anomaly and change and compare the anomaly with the previous result. Yeah. Do you have any questions?
Yeah, I had a question about the profiler. But you have to compile your binary with some certain compile time flags for Coroot to be able to do that, right?
The binary should contain symbols. So without symbols, Coroot cannot convert offsets into meaningful function names.
I have a question too. Is Coroot a multi-tenant or single-tenant system?
Multi-tenant, and we have projects, which means clusters or even wider thing. For example, here we have a set of nodes, for example, a Kubernetes cluster. But into this project, we can also add a standalone bare metal server for databases or VMs. And for a different environment, we can create another project and switch between them. Or like in the latest major version of Coroot, we introduced multi-cluster support, where you can even see how your components communicate like in different clusters.
That sounds very interesting because in Cozystack, users can spawn multiple clusters, and that would be nice to provide them this kind of monitoring enabled by default. But I was also thinking about replacing our existing monitoring stack. The main thing here that we actually consume Kubernetes namespaces. And in those namespaces, users can run a various number of Postgres, Redis, Rabbit, and MySQL clusters, as well virtual machines, and a lot of stuff. Is there any opportunity to separate them, to not let them see specific metrics from the other clients?
In like with our open source version not, but with enterprise version we have granular role-based access control. You can like limit a set of users to see only one application, for example, or application category, because in Coroot we have some specific thing we call it application categories. For example, here we have a set of applications in the category called application. But for example, we have also control plane, a set of application like Flux operator, Kubernetes control plane, and to be able to like easier to navigate through your application, like with many application, you can enable, disable, and see only the particular categories or any combination of them. For example, here in category called monitoring, you have Coroot, and you can understand how Coroot components communicate with each other without the need to dig through this complicated service map.
I guess what Andrei was asking is, can the boundary of isolation be a namespace and not a cluster?
You mean? Could you clarify what does isolation
Isolation
means
between tenants. So like one user can only see the logs and the metrics of pods launched in his own namespace, but not in other namespaces.
No, if we're talking about projects, like you set up an agent and configure that to send telemetry into specific project. For example, if you install the node agent on a specific node and it gather all the information about containers on this particular node, like across all namespaces. So you can isolate like at the permission level, but it's available only in Coroot Enterprise Edition.
I see.
Yeah, I think that
like I can show like a bit more if you have time.
I have a question. Can user define their own metrics here, or how is it usually works? And just for example, we have a use case. User is creating his own Kubernetes cluster, and they want to collect metrics from their application. How usually it works, and in case of Coroot?
Yeah, under the hood, we use Prometheus Service Discovery. So our cluster agent can discover and scrape metrics in the Prometheus format. You just need to annotate your like applications, and Coroot will discover and scrape them as Prometheus does.
And what about
here in
dashboards?
Yeah, you can create your custom dashboards and visualize. Oh, something happened here on our demo, But you can
Is it
create and use PromQL to configure like as Grafana. Not so feature useful as Grafana because we have only time series type of like time series panels. You can like configure basic stuff, but if you need full featured, dashboard agent, use Grafana.
interesting? Does it support also if it is compatible with Grafana dashboard format?
No, we just initially we tried to integrate Persis, but we found it difficult, and we decided to go with a simple way, just without basic, you know,
All right.
not DSL, but basic specification format.
Okay.
But no, because we are small team, so it's pretty hard to follow the standard because sometimes they are super like over-engineered and complicated.
Yeah, I understand this. So from the Cozystack perspective, I think that Coroot can be fine to be installed into user clusters because we actually have no normal monitoring installed there. For the infrastructure needs, we have Grafana with also already pre-configured things for all the basic applications. And since Coroot does not support the multi-tenancy in open source, I think it is not possible to use it in consider to replace the existing monitoring stack.
No,
I
multi-tenancy
don't
is
know. I
supported
think
in open
it's
source, but you like cluster general, I would say. So if you provide users a dedicated namespace in a like shared cluster, yeah, you cannot manage permissions. So
I guess your boundaries are that's the infrastructure, the server in which Coroot node agent runs. All of the data from there is collected. Is that how it works?
but basically you can exclude, for example, some namespaces or containers to be covered with Coroot BPF at the agent level, so it even will not be collected. For example, you can disable capturing logs for some containers or configure like exclude a container entirely or namespace, whatever.
Andrea, I still think this has value for Cozystack administrators who still need an overview of the entire platform. And it looks like a useful tool if you need to debug. You've got all the logs, all the stuff in one place.
Yeah, same like we have in Grafana, but with after configuration, which I like. Nikolai, do you have experience with installing these EPF collectors on Talos Linux?
Yeah, some of our users reported some bugs and issues, and as I remember, we fixed the majority of them. So it should work
Cool.
on Talos.
Cool. Do you have any support in GPU workloads? How it actually communicates? If it can show some metrics about GPU consumption?
No, we don't have GPU here in our demo stage, but in general, Coroot support GPU. It works like when you install the agent, it tries to find NVIDIA drivers on the host, and if it can load the NVIDIA library wrapper, so it will detect GPUs on the host, and also it can detect GPU consumers. So on your application, for example, you installed the Olama on Kubernetes, and Olama uses some GPUs. You will have a GPU tab on your application view, and on node view, you will have also GPU metrics. For example, the CPU and memory usage of the GPUs and GPU consumers and temperature, like the basic. But it also works without any integration. So
Sounds very interesting. One more question. Do you support OEDC authentication in open source version?
no, only enterprise will support single sign-on SAML.
And how it works in case of open source version? Will it have
Open
just
source
user password?
version, yeah, user password is some basic roles. Here we have a demo with limited permission. It's like public demo. So you have in open source version you have 3 predefined roles like administrator, read write, and the read only user. So you can assign a role for each created user.
And for the metrics, do you use ClickHouse as well?
Recently, we added a way how to use store metrics in ClickHouse instead of Prometheus. But it's at the end, it's like here you can click or configure through the custom resource, but still you will be able to build dashboards with PromQL because we use just ClickHouse as a storage layer, and on top of them we use Prometheus for eval, calling functions and like executing PromQL on top of the raw data.
Okay.
So
I see you also have remote write URL.
So yeah, basically with this new feature, you can use Coroot with just ClickHouse for storing everything.
Okay, and by default, do you use Prometheus?
Yes.
Okay. So I guess it also should work fine with Victoria metrics, which we have already.
Yeah, like fully supported, even in the clustered Victoria metrics.
Well, that sounds really interesting. Thank you for this introduction. Do we have any questions to Nikolai?
Yes, I have a question about tracing. Can you maybe explain a little bit how it works?
Tracing, what does it like?
Traces, I guess.
Traces, yes, traces.
Let me show. First of all, our agent can capture requests at the BPF level between components, for example, front-end call some other service. And the BPF level, we don't actually have distributed traces. We call it traces, but in fact, they are individual spans. Like we capture only one call, and without having trace ID, we cannot group them into a distributed trace like call chains and so on. But it's useful to, for example, discover anomalies. You can find like slow requests and see what happened there. But to work with full feature distributed tracing, we invite our users to use OpenTelemetry SDK. And when it's configured, Coroot can work as an OpenTelemetry tracing backend and to use ClickHouse to store them. And you can work with them as usual, like find some anomalies, see the full distributed trace, analyze span attributes, and so on. But additionally, we provide more features. For example, if you want to understand what's happened with all errors here, or red areas here are errors. So we can select them and analyze traces one by one to understand what's happened. But with Coroot, you can ask Coroot to summarize like all the traces here, and it find like 100% traces related to database, to PostgreSQL database. You can cross-check it by analyzing a sample trace and so on. Additionally, you can select any latency outliers. Here is a heat map. So it is here is like request performs like from 500 milliseconds to 5 seconds. And we can also analyze them one by one and understand like what spans took the majority of time. But with Coroot, you can use Latency Explorer and see the flame graph with span duration. So you can easily understand that here the majority of time spent waiting for a PostgreSQL database. Additionally, you can compare traces attributes within the selected area with a baseline. It's useful when you have some requests performing slow because of some specific customer ID, and you can easily detect this using this feature. That's just our idea and perspective how engineers should work with traces for troubleshooting.
Okay, thank you. That looks awesome. And one more question. Do you have some kind of network flow visualization, like S-flow stuff or something?
Basically, we have a service map that includes the amount of traffic transmitted and received between each component. Here on the connections, you have traffic indicators. Additionally, Coroot measures traffic between each component. For example, we know the outbound traffic to service catalog, and we can see the amount of traffic transmitted or received between every component. We use that for calculating costs. For example, when you run your cross-AZ application, we can calculate cross-AZ costs out of the box just because per application. So we can find the application generated the majority of cross-AZ traffic or internet egress traffic. In this case, application called catalog generators consumes $63 per month. It's an estimate. Don't consider this as precise values, but it's useful when you're working on cutting your cloud bill.
What
That's
is
really cool.
overhead for if you compare it with Hubble, just for example? Because I heard that
I'm not
Hubble
sure
is very resource consuming. They also use these BPF tools for collecting the data, and now I have worries about.
No, we have a benchmark published on our docs site, and for example, if you're talking about performance impact, there are two primary things. The first thing is that eBPF itself provides you with some guarantees. It doesn't allow you to run complicated program and interrupt the kernel execution for significant period of times, and that provides you some guarantees that BPF instrumentation itself will not slow down your application. The second thing is a user space part of our agent, analyzing this data that we got from the kernel. And here you just can limit, for example, set CPU limit for the agent. And if it can proceed all the traffic, all the events, you just will lose some events, which is fine for having guarantees that there is no performance impact and having as much precise data as possible. So we try to balance our benchmark. In our benchmark, we installed a HTTP server and HTTP client on different nodes and perform 10,000 requests per second and install the agent. And we will not have any performance degradation, even like a fraction of the percent. And that's why we can be confident that if you limit the agent CPU and memory, your system will not be impacted by.
Thank you. So I think we have 20 minutes left. I would like to discuss a Cozystack operator design. So I'll share the chart. Yeah, thank you for presentation, Nikolai. And now we'll switch back to our cozy things. The thing is that we have prepared the pull request. Was prepared 3 weeks ago, and now we're trying to split it to multiple smaller pull requests to get it merged. This pull request also introduced the Cozystack operator logic, and I would like to discuss with community the things, how it actually should work. The original design of a Cozystack operator was that you can start from the beginning. Let's say you have simple Kubernetes cluster with nothing installed yet, even no kube proxy, no CNI. So you can install Cozystack operator, then you can configure the system itself. Cozystack operator operates with two kinds of resources. First kind is platform, and it actually targets to Flux-CD Git repository or OCI registry. In those sources, we expect to having specific platform chart with the values which you can use to build your own platform, actually. Building your platform means that you put specific bundle resources, which actually defines which resources, which components should be installed in a cluster. And as well, application definition resources, which actually defines the applications for the users. We already have Cozystack resource definition, so that does exactly the same thing. That's just renamed. So the idea that you can create your own platform chart, specify the components you need in a bundle, and they will be delivered into the system as external artifacts for the as Helm charts installed in the cluster, because they're bundles and they have to be shipped together. And as well, artifact generators, which will generate artifacts, Flux-CD artifacts for the user, which actually using Cozystack API and can actually create Helm releases out of these external artifacts. That's a basic design we had. I would like to invite you to talk about that a little bit. What do you think, if it's wrong or not? Should we review this logic somehow?
I have a quick question. So from now, with the system where we have Helm releases packaged inside the container, we can make quick tests in our development environment. So we just build it locally, we push those images to Cozystack cluster, and we have our developed product right in the cluster. And how it will work in this case? Can you tell a bit more about this?
Yeah, this design actually covers few cases. The case one, just for example, user wants to change something in Cozystack, but that want to push those changes back to the upstream. So in this way, they're allowed to fork our Git repository, and they can simply to reconfigure platform chart to be installed from their Git repository instead of our one. Another option, if users want to extend the platform with their own applications. Just for example, we had before. user wants to install, to have the opportunity to have MongoDB clusters to offer them to their users. In this way, they just prepare another Git repository or OCI registry with bundle, which includes Helm release for MongoDB operator and also application definition for installing this MongoDB application. And in this way, the application will appear in Cozystack dashboard. The user will be able to order it and install on their cluster. Sorry, am I answered your question?
Yep, seems so. So we just make our own Git repository and push changes there.
Yeah, the original idea was to switch from existing theme when we have running HTTP server on the in the cluster and Flux communicating with this with Git repository which runs externally. But after a while, I decided to also add support of OCI registry because it is easier to test the changes locally. You can actually perform and push your bundle very quickly, and you don't need to push those changes to the Git and wait until they reconciled.
I see. Thank you.
So for now,
I think I want to.
Yeah, please go ahead.
I think I want to ask one more time. What is a bundle?
Bundle is a set of the components which are tested and prove that they work together. So just for example, in our case, we're installing the set of system components and we need to be sure that they are working fine. So bundle is kind of configuration or let's say repository with the sources for the applications. So we can be sure that all the applications from this bundle and system components which they include will be working fine.
So I don't know. So perhaps the KubeVirt operator, KubeVirt CDI, and the KubeVirt instance types. This is all one bundle.
Yes, correct. Because they get managed and updated simultaneously. Maybe we need to think about making more smaller bundles. Let's say, what if we will have bundles for supporting just MySQL, or to have bundle which supports just Redis or RabbitMQ. For now, we have these bundles combined, and they split to their purposes. For example, we have EAS bundle, which includes support of KubeVirt, creating of Kubernetes clusters. Actually, everything which you can see in our dashboard under EAS category. The PaaS bundle includes all the databases like Postgres, MySQL, Redis, RabbitQs, and everything like that. Maybe we need to consider to have smaller bundles, but include exactly one thing. So
yeah, I think that would make more
optional.
sense. If you recall our discussion about having something the equivalent of a package manager in Cozystack. So these smaller bundles, they look a lot more like packages than the entire PaaS bundle.
I like this idea, but if the name bundle is still correct for this purpose, I don't like to call it package.
Well, yeah, but you're right. The name bundle is ambiguous and maybe even misleading.
I think in this way we can also get of bundles and just integrate the system components into application definition, or to have package definition or something like that, and include the system components required to here. Yeah, Nikolai.
Yeah, I'm new to your product, but it seems like you use Flux-CD entities like resources here, like a Helm release. Is it correct?
Yeah, that's
Yes,
right.
we
We
do.
do.
But why you just instead of bundle, you can use resource set, which is like also Flux. You don't need to invent anything new. No?
We can actually, one of the value of Cozystack that we're shipping all the components together, and we have pipeline which checks that you can order the services out of this. In final thing, the component is actually Helm release, but we use them on two different purposes. We have system releases, let's say Postgres operator, MySQL operator, so something singular which manage the applications which users install. And also we have our own API server which reads application definitions, and it lets user to see the specific applications. Let's say it's like custom resource definitions, but fully dynamic ones. So you can define your own application. You don't need to recompile anything. It will appear like kind Postgres, kind Kubernetes, kind MySQL. So we're just creating higher level API on top of Helm release objects.
Oh, I see. But it looks like an abstract kind bundle seems pretty close to Flux resource sets, but I can be wrong.
Resource set, or which one you say?
Yeah, resource set.
Actually, I
It's
didn't
like
know
a
about that.
Flux operator.
Resource set is in the Flux operator, so
Ah,
All right,
so
got
it's
it.
not pure Flux.
And maybe we should consider to re-implement Flux operator. Why are they useful for?
I can't say for in general case. I think it's similar to the Argo CD application set.
All right.
If it is similar to the Argo CD application set, that's not what we're looking for. Argo CD application set is like launching several applications. Well, let them be Helm releases across multiple Kubernetes clusters, but with different parameters depending on which cluster you're launching it in.
Yeah, I think that can be useful for creating IDP bundle, let's say, to deliver application from various branches and pull requests to have dynamic environments.
That will, yeah.
All right. I think I have to learn a little bit more about this entity. Thank you for your input. So the problem we're solving here is that we have two types of Helm releases. One Helm release is a system, and the second one is what is going to install when a user creates their kind Kubernetes, just for example. For all of them, we need to have artifacts stored in Flux-CD, and we need to have some definition. I would like to put every set of such applications into specific bundle, and we need to split them to smaller parts. We probably need to find better name for this. Anyway, I think that we found some consensus, and I'll try to check it out and come back with the resolution. Thank you. We have 5 minutes left. Do we have any questions regarding Cozystack or anything else?
I have a follow-up comment. So indeed, every application definition, and I don't know, maybe some things about the dashboard that go along with it, could be a separate Helm release, and we could just reuse Flux's dependency feature, dependency field, to say like, okay, if you want to install the MySQL application definition, then it depends on the Cozy MariaDB operator. And also, if you want to install the monitoring application definition, well, that thing depends on the CNPG operator. But also, if you want to install the Postgres application definition, that as well depends on the CNPG operator. And in that way, we don't have the problem of what do you do when two bundles need the same thing, and or vice versa, or two things need the same bundle or something like that.
That sounds really interesting approach. So yeah, we can have some kind of packages like in apt repository. All of them are system by default, because without them, we can't give the user opportunity to install some applications. But you're right that we can, we have to work a little bit about the naming. But I like this design. So the platform actually can be some kind of repository, or that can be bundle. But inside of this bundle, we have some sort of packages which can depend on each other. And we give a user choice to whether they want to provide their users to install MySQL instances or Postgres or something like that.
I have a question for Kintan, actually, as someone from the Flux community. I always experience a lot of pain when updating Cozystack, because quite often you've got some like minor changes. In our case, it's usually kubeOVM being rebuilt to a new version. Nothing really changes, but a new image has to be pulled and deployed. And so that means that the Cozy kubeOVM Helm release is being updated. But the problem is that almost every other Helm release in the cluster depends on kubeOVM being healthy and up to date. But in fact, we don't really care about that. We just need to know that the CNI plugin is installed. So we don't want to deploy any Helm releases before we install kubeOVM for the first time, but we don't want to have a cascading update absolutely every Helm release in the cluster just when we bump the version of kubeOVM. Maybe you know about this problem and you know some workarounds for this.
Oh, I understand what you're saying. I'm trying to think of a good way to solve that. And it sounds like we want some kind of a split, right? Can we say that the CNI is installed and depend on that only? Can we split
Something
it
like
into
that,
two
I
separate
guess, yeah.
contracts? Or yeah, because we can't just it's not the CRD that we need, right? We don't want any pods created before they can attach CNI because they'll fail. Or worse, they'll start with no CNI and then they'll need to be restarted.
Yeah, but when it's a benign version bump, it's perfectly fine to update everything else. It's just that we have dozens scores of Helm releases in our cluster, and a benign version bump of kubeOVM sends waves of status updates across every single Helm release, and that's not what we want.
Yeah. So the way we solve this generally, I think, is with the OCI artifact. Instead of everything coming from one single source, we will split each independent component into its own separate artifact that only updates when that component updates. So that way, the downstream trigger effect doesn't have like this. This is a monorepo problem because all of the resources have the same source that gets updated at the same time. So they
Most
all,
of the time, yeah.
yeah. Otherwise, all of those other releases could just wait, and as KubeOVN became ready, they would see that they had no change, or even before then, and so they wouldn't even go into dry run.
Yeah, I think Source Watcher and those artifact generators also solves this problem because they have content-based versioning.
Yeah, the Flux 2.7 advancements I haven't fully caught up on, but that's the one. There's a solution in Source Watcher for this.
Yeah,
You
I
can
think
split.
we'll build
Yeah.
up the Cozystack operator to use source watchers. The only thing I don't like that you need to have everything explicitly specified. However, it can be solved by code generators. All right, I think we have to finish up. Time is up. So that was amazing discussion. Thank you for intro of Coroot, Nikolai, and thank you for participating in Cozystack design. So see you in 2 weeks, and bye-bye.
Bye, everyone.
Bye.
Bye bye.